Hi, I'm Mark Saffian from AWR. I'm an applications engineer, and we're going to highlight today some of the new features in Microwave Office, the AWR 2011 release, and our electromagnetic simulator, Axiom. So what we have here is just a very simple microwave T setup, but what makes this different, you can see the results for this geometry. But in the upcoming release, we'll be adding a new capability called data sets. So on the project tree, there's a new item, data sets. And what we have is stored results for different geometries on the T-junction. So I can simply update results from a different data set, and we can see the results changing without having to reanalyze the electromagnetic structure. So you can see everything updates, the geometry, the results, and all these results are cached. We have the ability to cache results for all types of analysis. So linear, nonlinear, electromagnetic. The bottom line is that you run an analysis, and if you want to take a snapshot of that for use later on, for comparison or as a sort of zero datum, you have the ability to capture that and recall it in an instant without having to rerun any simulation. The next significant improvement in Axiom is the ability to parameterize an electromagnetic structure directly without having to have a circuit schematic in control. So here we have another simple microstrip T-junction. The reference plane de-embedding is something you should be familiar with from Axiom, but things like these shape modifiers, which allow us to specify inset, outset, notches like you see up here at the top, this is all new stuff for Axiom, and it gives us the ability to have an electromagnetic document be a freestanding document. Also, in terms of running analysis in Axiom, we have created Axiom now as an asynchronous engine. So when I run the analysis, I can now come in and do things in other windows while the asynchronous electromagnetic simulation is completing its tasks. Finally, we'll take a look at shape modifiers as they relate to electromagnetic structures. So what we have here is a standard Lang coupler. It's a 4-finger coupler, and at the ends we have the Lang feeds, which, as usual, don't really lend themselves very well to standard electromagnetic circuit-based analysis. These are simply geometries that are hard to build out of parameterized schematic elements. So with shape modifiers in an electromagnetic document, we now have the ability to take a complex feed structure like we see here, and as you can see, there's quite a bit of control that's been added to it in terms of the width and the spacing and so on. So the bottom line here is that if I look at my schematic, notice that the fingers are parameterized in terms of width and spacing. And what we want to look at in this view is the detail. I'm going to come in and change the width parameter from 12 to 15. And you'll see the electromagnetic feed structure automatically update based on that shape modifier. So you can see, even though the width of the lines changed, we still have a feed structure that's perfectly matched to that set of finger dimensions. So shape modifiers give us the ability to create dynamic EM structures that adapt on the fly to the elements that feed them in a user-defined manner.